Hello everyone, my name is Parth Kumar Singh and I am an alumni of IIT Jodhpur. Today we are going to understand a very wonderful question that belongs to the chapter Chemical Kinetics. This question was asked in IAT 2021 and this question is pretty much basic, but yet it is very difficult to understand sometimes if you are weak at interpreting the graphs and the information that is given in the form of the rate constants. So basically in this question they are saying based on the relative stabilities and barriers, right? Barrier means they are considering activation energy and relative stability means that they are considering the rate constant, right, or the free energy through the graph. Which among the following schematic energy diagram would best correspond to the reaction scheme shown below? K and K prime are similar in magnitude. Wonderful, right? So basically this K is same in magnitude, so you can consider it is everything is K right here. Now you have to tell them that which of these four curves actually represents this particular consecutive reaction pattern, right? Now very easy, very easy. If you just know the fundamentals of reaction dynamics, you will just do this question in 2-3 minutes, not more than even 2 minutes. I'll show you this. See, X to Y, the forward reaction is 4 times the K and Y to Z is 8 times the K. What is the basic interpretation that you get from this type of consecutive reaction? It is that X to Y, if it is producing a stable product, then Y to Z is producing even more stable product, right? So what you can guess from this, that the energy of X, the free energy or the potential energy of X is highest, the potential energy of Y will be lower, and since again the rate is again the double of the first one when it goes to Z, it means that Z is even more stable. That is why the reaction is fast, right? So Z is lowest, the potential energy, it means that your curve should be gradually decreasing for the values of X, Y, Z in the free energy. Can this be the right option, the B one? No, because Y's energy is more than X and Z, right? Or Z is fine, right? But more than X is what it is incorrect for. Now C could be a good option because the gradual decrease in the free energy is visible, but D is again the wrong option due to this Y, right? Now A is also a perfect candidate because X, Y, Z are actually having a constant decrease in the free energy, right? So these two are the valid candidates. They have actually cleared the round 1 of the your basically competition, right? Now we have to decide between these two which one is the correct, right? Now we will go backwards. So see, Z to Y, the backward reaction is 3 times the K, right? And Y to X is basically 2 times. Or even I am just about to tell you a way simpler approach than this. You need not to go even backwards. If you just look at this, the intermediate or basically transition state that forms between X and Y and transition state that forms between Y and Z has a significant energy gap. But here the difference is that the transition energy between X and Y and the transition energy between Y and Z has a reverse gap. Means according to this graph or curve, the transition state that forms between Y and Z has a very high activation energy. If it is so, then why the rate or how the rate could be faster? Because you know that the rate of a chemical reaction directly relates to the activation energy, right? You all have heard that very famous equation, Arrhenius equation, right? So which relates K to the basically activation energy, and we know that less activation energy will be responsible for a faster reaction. So if the energy gap of the transition state means the activation energy when we jump from Y to Z is more than this, then the rate should be substantially less when we jump from Y to Z, rather X to Y. So this graph also cancels out the perfect criteria as given in this particular consecutive reaction. So that's why our answer is option A, and this is how you do this, right? So very easy and simple. So if you like this type of reactions basically, and you want to watch this type of videos, you can always comment, and thank you for watching.